Parker here, Colton here, Abigail here, Colton here again, John here, Parker here. So good to see you. We got the first question. Let's start writing all of these down. Oh, did I mark yesterday's videos? I don't think I marked yesterday's videos. Don't tell anybody. Don't tell anybody. It's been busy. We got the Stats 1 exam coming up right here. So we got to put the marks. We'll do it after this video. Let's see right here. So let's go and add the first question is Abigail's question. Can we go over the first two parts of exercise number 3, exercise in assignment due Sunday for BS 320? So BAS 320. How is everyone doing? We are streaming, right? I think we are streaming. So say hey if you're in the chat. We got some more 320 I see and some 475. So can we go over the first two parts of number 3? So assignment 3, question 3. Colton says BAS 475. Let's see. Let me go to the regular chat. We'll bring up Mubot here. It has been, how's everyone's week doing? It's been a busy week. Oh, I wonder if it's still showing my backgrounds while I do that. It has been a busy week. 475. Assignment 3, question 10. Material growing today. Number 4, anything Park says, anything 320 related. Anything 320 related. So, and then Mubot is awake. Mubot giving out those Mubot points. Oh, there we go. We got it going. And we're going to write down the last question. I think we are streaming. Say hey if you're in the chat. I think we're live. Maybe we're not live. Maybe I am streaming out into the ether right now. Question 4. Hey, Abigail, great to see you. Hey, Parker. Mubot did not give away points. We gotta click the button again. He's just not. He's doing it. Colton sees me right there. Good to see you, Colton. Let me say hi in the chat. Mubot, you want to give out points? There he goes. He's giving out points now. Awesome. Let me bring up the assignment. We're gonna get the assignments up and going right here. We got some 320 and then some 474. Wow. How do I open so many tabs on my computer? I mean, I assume I open tabs by opening tabs. That's kind of by virtue of how they happen. But like a day goes by and I'll have opened like, wait, what just happened? How did that move? I went to click on 320 and it actually moved spots. What? There's a ghost in my computer. We lost some points. More points, Parker, right there. Abigail, hey. I've almost got the assignment for 320 up and going right here. I'm navigating around the computer, navigating around space. Oh, it's assignment 4. It's assignment 4, not assignment 3. Okay. So let's redo the note on this. Assignment 4 for 320. And with that, let's increase font size. And let's go take a look. Here we go. Question number 3 on assignment number 4. And we're right here at the, put this over to the side. We are currently at the 4-minute and 10-second mark. Let's go do this. Okay, so this assignment is all about 2 quantitative variables. So if we're talking about 2 quantitative variables, what kind of relationship are we talking about? So think about this. 2 quantitative variables can be said to be this. So there's lots that you can say associated, but 2 quantitative variables, besides associations, have a special kind of relationship. So what is their special kind of relationship? 2 quantitative variables are said to have a what? Sometimes positive, sometimes negative, mostly linear when we talk about it by Pearson's standard. 2 quantitative variables are said to be what? And we're going to scroll down here to, I think, question number 3. You can quickly get to question 3 by doing this. Is there question 3? There's question 3. Should have a mark for it. Oh, it doesn't have a mark. Let's add a little, use a core demo. It's correlation, John. Great job right there. 2Q, 2 quantitative variables, is the standard by which we have to talk about correlation. So if you're talking about correlation, you're talking about 2 quantitative variables. So if you say like things like gender is correlated with the state you're born in, well, probably not associated, but correlation wouldn't apply to that. Correlation only applies to 2 quantitative variables. So we have the core demo right here. We'll do a little bit of this. We'll start this out right here, question number 3. And so it says use the core demo. How to get to core demo? You know what we could do? It should be doing, I thought it should be putting, we can make it so as a chunk. If you ever want to quick navigate, you could put like a Q3 chunk. Now, don't try to knit core demo. I'll put this here to find this quickly. because the thing you might not know is you can quickly navigate around it. It's just that there's no coding that will do there. Now, one thing I want to point out is when you run core demo, you need something running to run core demo. Who knows, for 100 points in the chat, to run core demo is located in a certain spot. Where is core demo located? Like, it's a function. Now, it might run for me. It is going to run for me. Where is core demo located? And the answer is on the screen. If you type core_demo, it might not show up for you. You need to have this running. If you don't have this running or you don't have this installed, so you have to install it, then you have to run it, and then you can run core demo. Those are the steps needed. So someone's going to be like, wait, core demo, I don't have core demo. Where's core demo? Core demo is located where? So use the information on the screen to help be like, okay, core demo is located here. So we have to know what we're doing. It's getting hotter in Texas. Core demo is located where? Where would we go to get core demo? Who knows? Core demo is located where? Use the information on the screen. Reg class, Abigail, you're exactly right. Reg class. That's what that info means right here. When it says reg class next to it, that means it's in the regression class package. So if you don't have it, you need to make sure you do install.packages, reg class. Now you can't knit this. Actually, it's someone trying to knit it this morning. Shout outs to you for emailing me and saying, Brian, this wouldn't knit. I could do a block comment on that. We'll comment it out the hard way. You have to install reg class, then you have to run library reg class. And so it's already loaded up, hence I could access it. Now we've got the core demo. What is core demo? Core demo is going to allow us to look at correlations. What is the, be careful as I ask this, what is the lowest possible value of correlation? What is the lowest possible value of correlation? That doesn't have any correlations, 1 point. What is the lowest possible value of correlation? Every time you reboot R or every time you want to knit an assignment, Parker, great question. When you knit an assignment, you have to make sure to have reg class in there because it starts a brand new instance of R. So if you knit an assignment, you need to have reg class before you do any reg class stuff because it starts R new when you knit. It says like brand new instance of R and then starts knitting. So if you're going to knit an assignment, even if you have reg class running, you will need to have library reg class because you're going to call that library to use the functions in it. There is an alternative way to call things like core demo without booting reg class. And you could call it this way. This calls the function from the package right here. So this would not require you to do it. So some people actually use that format to call things if they're calling like one thing, because then you wouldn't load all reg class. This says look inside the reg class package for core demo, where this alternative code right here would require reg class to be running to load it. But the first line of code, line 93, goes to the reg class package and then uses the function here. The next line of code assumes you have it currently running via library reg class. Parker, great question right there. Just understanding what the program is doing is very important. And who knows the lowest value correlation? This is a 201 question too. 201 we should know the lowest. Now be careful. I'm saying the lowest possible value. You might interpret it a different way than I'm trying to say it. I'm saying like in terms of low numbers, when you think of like the lowest number it could be careful because you might miss, I don't want to say the word that you might interpret as, John, don't worry, 100 points. That is the weakest. And Parker, don't worry, I'm throwing another 100 points, both wrong answers right there. That's all right. The lowest possible value of correlation in terms of like number scale of highest to lowest numbers, the lowest possible value of correlation, Abigail, great job, more points to the chat, is -1. The lowest now, oh, look, I can't even get a negative. There we go, -1. So that is the lowest possible value of correlation is perfect negative. And it's pretty close to -1 right there. So -1 is the lowest possible value of correlation. The highest possible value of correlation is 1. I oftentimes ask trick questions that, not like trick questions, but I ask questions I know people will get wrong usually to check knowledge. So I just want to give a huge another 100 points. Thank you, because I try to come up with questions I think people get wrong. Now, this is known as the what is value of correlation. This, I'm trying to show you the what is value of correlation. So think about Brian is trying to communicate to a very, I don't want to say it, it's a 4-letter word. It means not strong. This is a very what correlation right here, hence by this value, because it's closer to, wish we could get it perfect. It's negative now. Oh, really? Really? There we go. Weak. This is a very weak value of correlation. My plot goes to the top left corner where we add code. It looks like it's a mouse issue. Nana Bryant's been talking about this on the Discord. It might be a mouse issue. Try, if you have an external mouse, try that. Abigail, you're the third person I've heard that this is impacting, and I never saw it before this semester. I will also allow you to take pictures from online if you Google something and find a picture, or you can draw it out and put the values, like pretend you're just putting the value of R right here. I will allow you to draw it out. If you feel the grade is not fair to you, just please tell me. You're the third person I've heard that's been impacted by this. And that's out of like 200 students. It looks to be a problem more so than I like. The first student, I was like, oh, that's a weird problem I've never seen. The second student, I was like, oh no. Third, I'm like, oh no, 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 no. So Abigail, thank you for mentioning that. We think it's a mouse issue, and Nana Bryant made some comments on it this morning in the Discord. I'm unsure what's happening. People are saying that they're like clicking down here and then the point's clicking over here. First time I've ever seen it this semester is, yeah. And so thank you so much, Abigail. We'll make sure to communicate to me, and you can use pictures. You can draw it out. Just take pictures with your phone and stuff. And then we'll make sure to give you, like, if you feel your grade not fairly, just let me know. We'll make sure. Because it shouldn't be doing that. I've never seen it until this semester. And I even looked at the function, tried to recode the function for one student and didn't fix the issue. You're welcome, Abigail. Thank you so much. So the first one says right here, positive linear heteroscedastic. Positive is the what? This is a review for 201. Positive is the what of the correlation. If you hear positive, you're just telling the what of the correlation. Do I have 201 notes still open? I do. I got the 201 notes open because it really summarizes it well. Positive is just the what of the correlation. That's why I love 320 201. It's like if you do well in 201, you come in with some 320 knowledge. Yeah, you'll be ready for 320. So positive is just the what of the correlation. Positive. What is, when we say positive, we're just communicating to someone the what of the correlation. Positive is going to be communicating the, let's see if people know. What would positive communicate? The direction, Abigail, great work right there. The direction. Where linear indicates the form and heteroscedastic with a K or with a C indicates an unusual feature. A 201 student said, well, wait a minute. I thought only they said outliers because that's really the only thing we talk about in 201. I said, there's more, but wait, there's more. So I'll do two of these, but here's positive. That's linear. But heteroscedastic means the plot needs to, in some way, not just it has to go in this direction, but heteroscedastic means it needs to have what? Like, what does heteroscedasticity mean? Heteroscedastic or heteroscedasticity. So I started by making it positive and linear, and now I've added on some heteroscedasticity to it. So hetero means differing, and then scedastic means spread, probably. But hetero does mean differ, and homoscedastic means same. So if you have the same spread throughout, like a similar spread, that's homoscedastic. Where if you have a differing spread, make sure to, John, I might need to take a look. Oh, and I know we got things fixed up. So glad to hear things are fixed up. But you should see it's running right here. It should have like this running button, and then you'll have to hit end. Try hitting end, John, and then make sure when you do chord, you might be running it inside of here. John, are you running it down here on the bottom? Go to the very bottom where it says down here on this. Go to the very bottom of the screen. This is a common issue too. Go to the very bottom of the screen, and then go ahead and hit enter down here, and then it'll open up in this window. I think sometimes people run it in a chunk below, and if it's running down here, that's where a problem can often be. So make sure to try to run it right down here on the bottom of the screen, and then it'll open up in this window where you can click on it. If you run it in one of these chunks, you will often get it down below, and then I don't think it'll let you add points. So, John, did that fix the issue for you? Run the core demo. Abigail, 100 points again. Thank you, Abigail. Yeah, just let me know. I've seen a lot of issues over the years. And so hopefully, like, you're like, hey, it's not working. And I can hopefully, with my knowledge of what I've seen, good thing I'm not doing this for like the first semester online because it was my first semester. But luckily, I've seen a lot of issues. So I can be like, I bet it's this issue I've seen before. So yeah, that's a very common, don't worry, like Abigail and John, another 100 points. Yep, thank you for communicating that. The second one here, negative nonlinear. Well, that means it needs to what? Negative nonlinear means it needs to go down. Y or N in the chat, is this negative nonlinear? Is that negative nonlinear? Yeah, Shiv, you bet. Which is a question 4. Let me put that on the sheet over here. Got that we're going to do a 475, then we'll do a 320, then we'll do a 475. It is a upper level class today. Assignment 4. You bet, Shiv. No, Abigail, you were right. How about this? Now, this is negative nonlinear. And also, it starts with an M for 100 points. This is now negative nonlinear. And it was negative linear till the point here. Now it's nonlinear because it doesn't well follow a line anymore. But this is also starts with an M. Remember your favorite band. Let's review terminology right here. I've also made something that is what? Now, you don't need to add it, but I've also made something that is also described by a what relationship. It's negative nonlinear. This is also, it doesn't require this. It should kind of be this, though, if it's negative, because that says it goes in this. It goes in one direction. So what is the word right here that means one direction, your favorite band? Think One Direction. How would we describe One Direction? What is the terminology we say for that? Which is, you don't have to memorize this word. I mean, you maybe should because you'll hear it sometimes. But when we talk about this sort of form, it's a blank form. So mono something, I'll take that for 100 points. Monotonic, right there. And then great question, John right there asks, well, how are we going to take these and put them onto our assignment? My number one way to put these onto your assignments is to take snipping tool right here, or on a Mac, hold Command Shift 4. If you hit Command Shift 4, so let's take, I think we got so many things open right here. So many things. Okay. Brian's advice. PC, snipping tool. Mac, Command Shift 4. Add in after knitting. Okay. So what are you going to do? This is my top advice because I see students who submit assignments without these. When do you add these in? Boop. I'm going to delete all this nonsense right here. You could put them in your working folder, but I've had so many students submit these assignments without their images. So what is the best thing to do right here? What are we going to do? We're going to take this picture right here, and we're going to store it on our computer as a saved screenshot. There we go right there. There's our saved screenshot. We're going to knit our assignment because we've already completed it. We've got every image stored, and we're going to knit our assignment. Hopefully I haven't got any errors right now. I'm knitting the assignment. Should open up right here. So I've done all my work. I've knitted the assignment, and I'm going to go look on my computer. I'm going to go down here to where it says 3B and where it says during scatter plot. No, wait, that's not the one we're on. That's question sometime. Here's question 3. So negative nonlinear, it doesn't say monotonic on the original assignment. And I'm just going to drop that right there. Does that make sense, John, right there? I'm going to take, and then I'm going to make sure this is in here. And then also review your document for any excessive output. So you want to like go through and be like, okay, am I doing too much here? Do I have too much output here? You know, you can even just delete things you don't want. Like, I'm not saying delete that, you shouldn't. But after you knit your document, wait till we make the plot, knit the assignment, and then screenshot the plots. Yeah, I would drop this. I think, Parker, that's the best strategy because I've had a lot of students be like, I'm going to make it coded in there. You can use, it's got instructions for putting it in there. But frankly, like I used to have students who be like, oh, let's do this. Okay, where is it saved on your computer? Where's this? Where's that? And then I found the easiest way is like, okay, just knit it. And then also check on it when you knit it. Could do the image knit for number 5. Yeah, James, good question. We'll do that here. We got the list of stuff. So we're jumping back and forth between 320, 474. So assignment 4, I think this is all assignment 4 for both classes. Oh, no, yeah, it's assignment 4. Oh no, I think 475. And then question, I think you said 5, right? Awesome. Let's head back here to the main screen and we'll jump back to that, James. You got it. Thank you, everybody. How do we clear the plot? Hit end and then rerun the core demo. So there should be an end button. Abigail, tell me if it doesn't work, or Parker, tell me if it doesn't work. But there should be an end button. And then after hitting end, rerun it. So make sure to hit end, and that'll be in the bottom left corner. hit the end button, and then it'll stop running it inside of your R, and then run core demo again. So there's no like global clear of the plot. You just kind of finish your plot. Bar. So hit end and then rerun the code to run core demo. And that's how you can get a brand new plot to start over. People saying hey to each other in the chat. I'm going to send out a quick link. Brian's doing work. Gonna send out a Zoom link. I'm actually joining a Zoom meeting. It's so crazy. It'll invite, copy invite link. Gonna meet with someone in a little bit. End meeting for all. Okay. Sending out the link. Then we'll do some 475. Okay, got it. Alexa. She can't hear me. I'm gonna set an alarm with Alexa to remind myself. It's hard when you have meetings to sometimes remind yourself, like, I have a meeting at this time, like when your daily schedule's a little bit different. But I've got a bunch of reminders everywhere. What's assignment 3? About to do some assignment 3 for 475. So if you want to hear, I do have it marked as assignment 3. It was finished on mine. Finished. Nice job right there, Mac. Great job. Thank you, Parker. Let's go over here and do this. Okay, so this is right at the 22:30 mark. And we're doing BAS 475 assignment 3, question number 10. Oh my gosh, what have we done? Finish. Yeah, the finish does it too. There we go. Clear out that plot. Clear out this. We're going to basically start a brand new instance of R over here. And so even if you're 320, you're going to get to see some cool code right here. There we got the stuff right here. Use the following code to compute the daily changes in Google closing stock prices. It's mad about something. What's it mad about? Argument key is missing. Maybe. Now this loads in because this is in the library FPP3 package. So you would need to have library FPP3 running, and it's going to store into that right there. Everything worked, even though it's apparently mad at me. That's fine. So I kind of alluded to this. When we talk about the index is a what variable? Index is a what variable? Index is a what variable? Index is a... I know, right? Isn't it weird, Colton? Index is related, which means we're going to be doing time plots 201. 201 knowledge comes into play right here. Index is a... kind of tells you what the index is related to. Index is a variable related to what? When we talk about how things are indexed in a TISBL, that's something that has a certain... Good answers right there, Abigail. Not quite categorical. Index is going to be a time-ordered variable. So when we talk about how things are indexed, that's going to be a time-ordered variable. So Abigail, great answer right there. It's going to be time-ordered. And we're going to plot this right here. And here's the plot of it. So when you see trading day right here, do we have to re-index because it accounts for... Boom, Shiv, another 100 points. Yeah, that's... Which I think I kept mentioning that in the... If you watched the last lecture, I was talking about how like trading days are kind of weird. And so they have a way of updating to trading days. And it's like the regular trading days. So they have a way of updating a TISBL so that it's indexed by trading day. So the distance right here is what? Like, explain to me what this difference is right here. Like, this 100 versus 101 have a distance of what? Like, every distance right here is what? I mean, it should be kind of obvious because we've re-indexed on this. So every distance is a 1 what? Like, I mean, Aaron's kind of, I'm like going crazy today. It's a 1 what? If you talk about, oh, the time interval difference here is a difference of 1 what, which makes sense why we're re-indexing on this. It's like, we can't do it by each day because that's not like a constant unit of time. Even though 1 trading day, yeah. Even though so it's not quite day. Sure, you get an answer right there. It's not quite day because day is not consistent. Like, if you think about like stock trading tomorrow versus stock trading on Monday, well, they might not even have traded stocks this Monday because it has to be a trading day. So when we talk about a difference of 1 right here, the time difference is 1 trading day difference. Even though 1 trading day difference is not constant, everything has a constant difference right here of 1 trading day. That stock was traded on this day, like day 100 and then day 101, and there's a constant difference. This is very important for time order data, that there's a constant difference. And for 201 knowledge, this is a time plot. Time plots have some time variable, like a trading day difference on the time axis. Last question for 100 points. All time plots are what? 201 knowledge review right here. All time plots are these. Here, I'll give a hint. 201 review knowledge, all time plots are these. Every single time plot is of this. If you're making a time plot, you're actually also making one of these. It's just time plots are special case these, is where time is on the x-axis. You're making a time plot, you're actually making one of these, but it's a special one. It's the doctor mug today. Trust me, I'm a doctor. He's also British, maybe. You're also making a scatter plot. All time plots are scatter plots. Quantitative displays of data. So what do we have right here? We have the plot of it, and we had to re-index it because days are not going to be well-defined distances. So we need a perfect, like, every unit of difference here by 1 is 1 trading day. Plot the differences and their ACFs. So I believe we already differenced. We already differenced it. So this data right here is already differenced. Let me explain what differencing is. When I run my code, it opens a plot in the code areas. This where you're talking about. Are you talking about down here, Spencer? You probably just have it where it's displaying below. If you want to change that, you can go over here to the R Markdown and uncheck this box. Let me show the steps for this. Thank you, Spencer. Good answers right there. If you want to change the way that's orienting, go to Tools. I'm going to do it slowly right here. Go to Tools, Global Options, Tools, and 320. I actually suggest doing this also. Tools, Global Options, and then go to R Markdown right here, and then uncheck this box, which will instead not put your plots over here, it will put them over here. I personally prefer to have them over here. It's just a preference. I just like my plots to be in the plot window. What a novel idea. If you don't have that checked, you will see them below. That's fine, but sometimes with core demo, that can cause issues. I prefer to have it where we do the plots, because plot window. Plot the differences and their ACF. Well, this is the differences right here, I believe, because we have taken close. Oh, we want to do diff. So this should do it. Oh. So make sure to plot the differences. I get the error, not Tisbel argument X is missing with no default. Run this code right here. Make sure, run this code right here. When you run that, are you getting, it's a Tisbel. Colton, does that show up for you? Make sure you run code already there. Is it doing what it should? You might, have you loaded up run GAFA stock? Make sure GAFA stock exists. Does GAFA stock exist for you? Oh, the autocorrelation function. Good question, Shiv. We'll do that next. Thank you so much for all these questions. So run GAFA stock, make sure that exists. If GAFA stock does not exist, load FPP3, then check for GAFA stock existing. At that point, you should be able to create the D Google right there. And with the D Google now existing, check to see if the D Google exists. If the D Google exists as a Tisbel, make sure it exists as a Tisbel, we should be able to do things like auto plot a variable inside of it. How's that looking, Colton? I'll troubleshoot it again. Tell me if it's good. Make sure FPP3 is running, which is where the GAFA stock vector is, or Tisbel is at. Check to see if your GAFA stock is there. You can double click it to run it. It does, and it says it's a Tisbel. I'm just gonna drop this straight in here. Run that code. There might be some typo that, like, grab that code right there. I'm gonna delete it in a moment, and then grab that code and tell me if it runs. That should theoretically run. If not, you might need to send me a screenshot or send me your .rmd on Discord. Couldn't think of what it's called, but that should theoretically run. If it says dgoogle is a Tisbel, then it should be able to manipulate that. Should. Everything's a should with code. Because sometimes code just doesn't do what we tell it to do, which is weird. Probably us. Probably humans not realizing the errors. Did that work, Colton? Should work. If not, we'll debug and take a look. So we will hope. Error. Can you send me your .rmd on send me your .rmd on the Discord, and then I'll take a look. Just send me your full. I don't know how to multi-pick scale for objective type function defaulting to continuous. What? That's fine. It's mad about sort of like it's missing one row of observations. Is it missing the first? Where is the missingness in this data? Let me look at the vector. That's not a bad error. Or warning, I think it was. Is it mad about that 250? Oh, the NA right here. It's mad about the NA. I wonder if I could remove that NA. And then, what? Yeah, it doesn't like that. Oh. Yeah. Don't know how to make... Okay. Yeah, send me it, Colton. Tell me when you send it. Just say sent on the disk. Say sent, and then I will take a look, and I can load it up here in the background and see, and try to replicate. Also, resetting R sometimes fixes errors. If you just reload R, sometimes it's like a graph error or something with some sort of function overstepping some other function. Resetting R can fix things. Did the changes in stock price look to be a white noise pattern? Sent. Awesome. I'll check out here next. So this is what Shiv was getting at with the ACF right here, which is going to tell us. Let me remember the code we use for ACF today. I think we use the Feast package. I think we're using Feast or Fable. I think it's Feast. Here's the problem. Here's my problem. There's so many ACF functions. ACF has like 1 billion functions. So if you ever see me going and looking at the book, I'm like, which ACF function do we use on Tisbles? And I think it's the Feast one. Ah, there it says Tisble. Well, that's a good answer. It is the Feast one. So we should be able to take and pipe into the ACF. Is it going to give it a variable? There's the ACF. And let's auto plot it. And there we go. We created the ACF and we auto plotted it. There's other ways to do it. I think the... Okay, Feast has this. Cool. Really? Must be... Oh, must be a Mabel. Give me 2 seconds. Model should work. Give me a second. 2 seconds while Brian creates what he wants. I'm creating a better display. I'm going to create a better display. I'm cool with this display right here. I'm cool with this display, but I want a better display. I want a better display. We always want better displays. Well, I guess you'd be using the mean. Mad about that. There it is. Mean to close. Oh, it's mean. There we go. Is that the same one? Might not be. Do you mind? Yes. Let's talk about the ACF is. So what is this ACF? What's going on with it? I don't know. It's not the same ACF. It's not the same. Is the naive? Let me look at one thing. That's not the naive anymore. Oh, maybe it is. Maybe it is. I'm looking at the. I'm looking at something real quick here, and I'm gonna explain. It's got significant autocorrelation on lag 8, I believe. That looks to be. Is it the same? I think it is. Pretty sure. Okay. I just like this graphic better. And now let's start talking about what is the ACF. Damn you. Doesn't like it. Okay. Doesn't want to do that. Okay. So the ACF stands for the autocorrelation function. Then we'll look at that next. The autocorrelation function is when we're asking, is a current point in time correlated to a previous point in time? So let's think about, and let's put a timestamp in this video because this is going to be today's lecture. what is the ACF? So here we go. 3540, BAS 475. What is the ACF? Once again, it stands for autocorrelation function. Auto means what? Just break down the word auto first. Auto means what? So when you think of autocorrelation function, ACF stands for ACF, autocorrelation function. There's the ACF of ACF. So what does auto mean? Not quite automatic. Good answer right there, Shreya. Not quite automatic. It's not the automatic. Good guess. 100-point guess. Auto means like if I talk about like, not like automatic. Here's a hint. That's a hint right there. It's funny, like automobile doesn't mean that. Auto means self. So when we talk about the autocorrelation function, we're talking about how it's something is correlated on itself. So if I have a vector right here, where the vector goes something like this, if we talk about the autocorrelation function, we're talking about how the vector is correlated on itself. Great answer right there, Spencer. We're talking about how it's self-correlated. So what would we do to talk about how something is self-correlated? So to find out the self-correlation of this vector, we can do it at lags. A lag is when you talk about a previous period. What is the lag 1 of this vector? So the lag 1 of this vector would say, go back 1 unit of time and look at the previous point. Does that make sense? So go back 1 unit of time and look at the previous point. So let's make a, right here, lag, going back X units of time and finding the previous point. So if we talk about the lag 1 vector, what would the lag 1 vector be? So here's our original vector. And then I want to know the lag 1 vector. So go to this point right here and tell me. So this is the hardest part of it. Oh, nice job, Colton. 100 points, Colton. This is the hardest question. You ready? What is the value for the first element of the lag 1 vector? The lag 1 vector currently has what right there? The lag 1 vector in its first position would have a what value? This is the hardest question related to what I'm trying to teach you right here. The current value for the lag 1 vector of this vector, like if we talk about a lag 1 of this vector, you have to go back 1 element on this. So this is the hard one to answer, which it goes to our knowledge of not quite 1. So let me ask you, is there anything before this point? So Shreya, great answer right there. Is there anything before the first element? Is there anything before this? This is the first element of the vector, and we want to go 1 before it. Is there anything before this? Is there anything before this? Is there? No, the 100 points right there. You got it. So the lag 1 vector would have what as its first element? Since there's nothing before it, remember there's nothing there. Nothing at all. It's missing. So what should I put as the first element of the lag 1 vector? So the lag 1 vector, which is like, if we talk about like lag 1 of this, then what would be the first element? Remember, there's nothing there. You can't go 1 before it. Not quite null. Not quite null. Good answer. It's missingness. It's missingness. Null is a object which stands for nothing. NA is a object. I guess an object. It's a thing we can put in for missingness in vectors. Now the next element is going to be what? So you have to go here and say lag 1 this. So now you need to go 1 element before this. And so great job, Abigail, right there. Yep, NA. So what is the second element of the lag 1 vector? What is the second element of the lag 1 vector? So you want to go here and go 1 element before it. What is the second element of the lag 1 vector? It's 1. And guess what? It would just follow this pattern right here. How about lag 2? Okay, so let's do the hard part again. You ready? If we make the lag 2 vector, what is 2 elements before this? If we make the lag 2 vector, what is 2 elements before that? So you're at the 1, you need to go 2 elements before that. What is Shreya, you're seeing it. Yeah, Shreya's already got NA, and then it would just follow this pattern right here. Once again, it doesn't go all the way because the last element of this would be, you'd be at 20 and you'd have to go 2 elements before it. So the last element of the lag 2 vector would be here. Now, when we talk about autocorrelation, what we're doing is we're creating a lagged vector. Does that make sense? And then we're correlating that to the original vector. So this right here, we would literally take these two vectors, go over here in R if we were to do this by hand, and we'd have here vector 1, or let's say vector. And there's the vector. And then we would go here to lag 1 of the vector. And we would go here and go correlation. And this is all done for us by the graphic. I'll explain what the graphic is showing. And then we do this right here. And we see the correlation of the vectors. So there's a very high correlation on the lag 1 of that vector. So what is this graphic communicating to us now? Does that make sense what lag correlation is or autocorrelation is? You're taking your original vector of data and seeing if the y variable is correlated on previous points of itself. Does that make perfect sense? So if we look at the ACF of the data, we are looking at, and we'll just run just the ACF of the differences, we are asking, is the y variable correlated on a lag 1 vector, and how correlated? Does that make sense? Like, theoretically, do you understand the theory of what autocorrelation is? To be make sense? Good. That's what we want to hear. So it's just making a vector of data from the original vector of data and then asking if it's correlated. And we could keep going to lag 10, lag 20, lag 25 to see where it's correlated at. And so here's the issue. We need some way to understand this, because imagine we were to go through and we were to do all of these. This would take a lot of time to make all these vectors, right? So what R does for us is it makes a vector with a lag 1 on it. It makes a vector with a lag 2, a vector. These are not the vectors. These are the values. What are you seeing right here where this looks to be about 0.01? This looks to be about negative 0.10. If you remember, we were talking about 320 correlation, how much every topic converges. What is the weakest possible value of correlation? We were just talking about this a second ago. What is the weakest possible value of correlation? This is why all of our classes converge. What is the weakest value of correlation possible? The weakest. The weakest value of correlation is what? The weakest is 0. Great answers, Abigail. And so think about this. The rock will tell you about the sign.
It doesn't matter.
What do you think these blue lines indicate to us? And here's a hint. What do you think those blue lines indicate to us? And they're not, it's not that, but they indicate where that begins. You're thinking, wait, it's relative to that, telling us where this, oh no, Abigail, don't worry, the weakest is 0. Because outside the blue bounds would indicate a correlation that is what? Which is, this is, and think, it doesn't matter if it's positive or negative. Outside the blue bounds on this would be correlations that would be what? Now, this is not the p-value, this is the value of correlation, but more extreme correlations would have a lower p-value and thus be this. More extreme correlations would have a lower p-value and would thus be this. So the blue bounds is telling you the what of the correlation you are viewing. The blue bounds is telling you the what of the correlation you're viewing. What are the blue dashed blue lines communicating to you? If the correlation is or is not what? Think the correlations close to 0 or within the blue bounds. The correlations more extreme might escape the blue bounds. It's communicating to you whether or not the correlation is this. Who knows the answer to that one? The blue boundaries right there are communicating to you whether or not the correlations are what? Ooh, we've asked a good question. Don't worry, just take a stab at it. Get things wrong here to get them right on the test. Colton, we're pressing every button. Statistical significance, because it's relative to p-value. Now, we don't know the p-value, we just know that this one is statistically significant. But here's the thing, and this is why people might get this wrong. A white noise process is random. Random stuff should have a correlation closer to what? Random processes, where it's just like not related to each other, should have correlations closer to what? A random process, which would be like a white noise process, where white noise is just like, hopefully there's not any bursts of noise there. It's completely random, just noise. No signal in it. Close to 0. So you look at this and you say, aha! That's significant at lag 8. But this is where we get into stat tool 1 again. How many tests did I run right here? How many tests did I run? So think this goes to 15, it goes to 20, 1, 2, 3. Oh, maybe I didn't run as many as I thought. Well, that's the answer. How many tests did I run? This is where stats one comes in major right here to understand that, yeah, it's a white noise process. That's the answer to the question. Someone just tuned out. They're like, click, it's a white noise process. But wait, it has a significant one right here. We just ran how many tests, though? How many different tests how many lags did we test to see if there's significant autocorrelation at those lags? A lot of them are very small. Some of them are moderate. One of them is statistically significant, but there was only one statistically significant out of 23. Abigail, you're right. That means 4% of our results came back statistically significant. Now, that's not a p-value. With an alpha of 0.05, what percent of the time should we get statistically significant results by random chance? What is our type 1 error rate by default? This is where it's important to understand what we're doing and not be like, oh my gosh, look at that. The type 1 error rate, which is your alpha, is what? We would expect what percent of significant results due to random chance. Random chance with an alpha of this would produce this percent of false positives by random chance. So what percent of the time would we have results that are statistically significant just by random chance using this usual rejection criteria, which is the significant p-value level? We would expect to see what percent of results statistically significant just randomly. The alpha level. Think of your alpha, your usual rejection criteria. So we usually expect 5%. Because alpha is usually equal to 0.05. That's when we say, we have results. Now, this isn't our alpha level. This is what percent of our results came back significant. It's actually 0.05 is the rejection criteria. So 5% of the time, we'll see results that are statistically significant just by random chance. We had 4% results statistically significant. So we actually got less than we would expect. Does that make sense to say, like, we ran a test right here and basically nothing came back significant? And so I'd say this seems like we would expect via random chance. Like, and it's not even super significant. It's barely beyond the boundaries. So I would say, I'd say this is pretty likely by random chance. I'd say there's not much going on right here. So I'd say this is a white noise process. Good stuff on number 10. Really great review. That was a pretty big review on what is the ACF and how to work this problem. We're going to head back over here to the main screen, but I think people should be good. Time for the main screen. Excellent stuff. We got some 320. Put on this song. Time for a little more 320. Let's head over. Remember, we're going to do some more 475 this year. Welcome, Abigail. Thank you for all those questions. Really, really great questions today. Like, not that they're bad questions any day, but I love working these things. I love talking through these things. Thank you for everyone participating right there. That's what matters to me. Here we go, doing some 320. Remember, all these topics seem to converge. Here we go. Question number 4, is this the Tyler Vigen? We had issues last night on the Discord. Why do we re-index again? Because trading day is not a consistent unit of time. Because each day is not a consistent 1 unit difference. Trading days are on irregular days. And so good for us. It can be updated via the Tizble thing, which finds out when the trading days were. And then we have a consistent unit of time between trading days. Check out the earlier portion of that question where we walk through and explain, the re-indexing. Is the site gonna work? We never know. You never know what's gonna break on Stat 201. Random things break on Stat 201. The site is currently broken. This was brought to my attention last night that the site is currently not working. I'll be putting out this announcement in class, probably sending it via email. The spurious correlations website, when you go to view variables, does not correlate, which means we need to go to his original webpage and do the following. 2 seconds. Since the website is currently broken, I will be putting out an announcement about this. I don't know when it broke. I don't know why it's broken, but it's worked. Everything's just breaking this semester. You're welcome, Colton. Excellent work. We will have to use one of the graphics on the screen currently. You have my permission to take one of these graphics. You can just screenshot it. Does that allow you to copy? Oh, you can just copy. You can download as a PNG, all that stuff. So you need to take one of these current ones on the screen, preferably with more data. like worldwide non-commercial space launches with sociology doctorates awarded, civil engineering degrees with how much cheese people are eating. Very highly correlated right here. People eating cheese and people getting degrees in engineering. So if we really want some engineers in the United States, I guess it's the United States, we need to tell Wisconsin to get on it. They might say this looks like negatively correlated, but this is not a negative correlation. I'll explain why. If one variable is going down, like the marriage rate in Kentucky is going down, and then the other variable is going, like the drowned by falling off a fishing boat, then they follow each other. This is not negative correlation because as one goes down, the other goes down. This is also not a scatter plot. It's a time plot. It's an overlaid time plot. So it's actually two scatter plots that have been overlaid, and they even do two separate axes right here. So it's an overlay, two time plots overlaid. Would I say it's not a scatter plot? It's not a traditional scatter plot. All time plots are scatter plots. Brian, you should know that. Come on, you just said it a second ago. So it's actually an overlaid, two overlaid time plots. So it's double scatter plots all day long. Double rainbows. So this is also a positive. Do we have any negative correlations on here? Any negative? Can we get a negative correlation here? Maybe we don't. Maybe we don't. So no negative correlations. Those would be if they don't follow each other, like one goes up, the other goes down. Either which way, one goes down, the other goes up. And so please take one of these right here and use it to describe the relationship you see. I will talk about that in class today and say the site is currently broken and you'll have to use one of those ones on their main webpage. So make sure you do that. It's currently broken. Report the two variables you selected, include the plot from the website. So I would take a picture and then I would store that picture afterwards. We were talking about that a little bit earlier. That Brian's advice is use PC snipping tool on Mac Command Shift 4 and then add it after knitting. So once again, knit your file. And then after you knit, this is a previous assignment right here, or previous question we did. After you knit, make sure to paste it in. Look through your document also to make sure you do not have any excessive output. So when you go to knit your assignment, make sure it's the work you expect to see. If you see a bunch of extra stuff, you can literally go in here and just delete it and say, I don't want that. Now, don't do that to things you want, but do that right there to things you don't want. Just delete it out. And yeah, I'm trying to think. I don't want to do too much on this one, lest since I can't do one that others can't do, but you see your spurious correlation, I would just literally go in here and just drop in that image. But once again, do it after knitting. Add images after knitting. 100% add your images after the knitting. Any questions about this question? We'll be talking about this a lot today, like what is a spurious correlation? It says report the value of R, calculate the value of R squared, interpret the value of R squared. So this is a really good thing to talk about here. R is correlation. Tool 1 should know that. Everyone should know that by this point. R is correlation, ranges from -1 to 1. These are not answers. Not answers. What is R squared? Does anyone know from 213, 324, 74 what is R squared, or 475, excuse me? R squared is a value what? R squared is correlation squared in most cases. Sometimes it's not quite the correlation squared, but it can be derived. If we have correlation, we can get R squared. But R squared is a measure of the percent of variation we understand in the Y variable accounted for by the X variable. You have to be very careful because R squared is going to be, is contained, or let's say it's actually called the coefficient of determination. No one calls it that. Coefficient of determination is contained between -0 and 1. Because it's R squared. If you square -1, you get 1. If you square 1, you get 1. And 0 is the lowest it can be, so it's contained in the values of 0 to 1, including those values. No one calls it the coefficient of determination. Only textbooks call it that. You'll hear it called R squared. So when we interpret the R squared value, it's usually blank % of the variation in Y is explained by the variation in X. Another alternative interpretation the book uses is knowing knowing X. See, I don't usually use this one. Knowing X gets you blank % of the way to understanding Y. That's another fine interpretation, so I'm okay with whichever one you use. Knowing X gets you blank % of the way to understanding Y, or my preferred methodology is blank % of the variation Y is explained by the variation in X. So when you think about this, you're just trying to talk about like what your x variables bring. Does my x variable help me understand y? Does my or how much variation are we accounting for? And we can see this a lot of times with statistical models very quickly by going here and doing something like miles per gallon explained by horsepower of a car. So we're just going to look very quickly at an r squared right here. And the r squared of this model is 60% or 60.24. So I would say, remember your XY combination, I would say knowing the horsepower of a car gets you 60.24% of the way to understanding the miles per gallon of the car. Now, that doesn't mean it causes more miles per gallon, but you're like, oh, this car has this much horsepower. Well, that would give you about 60.24% of the information in what the miles per gallon for those cars should be. Now, we could also say 60.24% of the variation in miles per gallon is explained by the horsepower. Be very careful when interpreting that your XY combination is correct, that if you're going to say blank percent of the variation in Y, miles per gallon, remember this is Y tilde X, is explained by the variation in horsepower. So to highlight what we're talking about, 60.24% of the variation in miles per gallon is explained by the variation in horsepower. And that's a good way. Can you explain the adjusted? Oh, good question right there. So we have not gotten to adjusted yet in 320, but that's such a good question. 100 points right there. The adjusted, and we'll put here topic for multiple regression. Adjusted R squared. So and such a good question. Thank you for asking that. The adjusted R squared, which is right here, is a more fair way of looking at the R squared. It's a penalized R squared. So let's write that up here. Not in, maybe covered in a month. So we'll maybe cover in a month. Maybe covered. But I always like saying you should know all the output, and hey, it's right here. So the reason we won't really care about this right now is because we don't have multiple x's. So adjusted R squared is a fair way to compare models where one model might have 2x variables and one model might have 5x variables. Think about two models right here. If we have a model with 1x variable, and then we have a model with 2x variables, or let's say like all the x variables, which of these models has an advantage? Which model right here, model 1 or model 2, would have an easier time? So let's just say 1var. And this is how you get all the variables. Which of these, the one with one variable or all the variables, would have an advantage? Does that make sense, Trey, when I asked it that way? Like, if we're trying to explain the miles per gallon of a car, which of these models would probably just have a better ability just by virtue of the way it's created? Would it be the one that uses one of the x's, or would it be the one that uses all of the x's? Which of those would have an inherent advantage? All of the x's, right? It's like, let's try to explain the miles per gallon with just horsepower, or let's use all the variables, which does include horsepower. So when you think about this right here, the reason we have adjusted R squared is we can then look at the adjusted R squared of this model, and here's the adjusted. What do you notice about the adjusted to the R squared? Adjusted will always be this to R squared. So when you look at the adjusted, it's a fair comparison between different models of different amounts of variables. That's the definition of it, pretty much. An adjusted R squared is an R squared that fairly compares models of different sizes of variables. And so adjusted R squared is going to be less than R squared. It's adjusted kind of downward. It's a penalized R squared for the increase in variables. So now we could say, yes, because someone could say, well, that has more x's. Of course it's going to do better. And we could say, well, let's compare the adjusted R squared of this model, which is 58.92. And the one right here is 80.66. So I would say this model is definitely better because the adjusted R squared is higher, because of course R squared goes up when you add x's, but the adjusted is a fair way to compare them. Does that make sense, Shreya? To fairly compare models where one has a lot of x's and one has a few x's, we have to adjust the R squared to fairly compare them, because the one with more variables will always have an advantage. So this will always be higher than the other model. But when we use the adjusted R squared fairly compares them. It penalizes us for adding additional variables. Yep, and that's why we call it adjusted. So using this right here, we can say like, well, let's compare two models fairly, and then you should use the adjusted R squared. It doesn't have an interpretation on like blank percent of the variation Y is explained by the variation X. It's just a comparison metric to fairly compare models of differing size of variables. Amazing question right there. I'm going to throw out a big 500 points for the bonus question not related to this assignment, points add plus viewers. I appreciate all those questions that go in depth because we will be learning this stuff later on. You're welcome, Trey. That's such a good question. And then when we get to adjust R squared, you'll be like, oh, it's just adjusted for how many variables in the model. It fairly compares variables. And you want to see something really crazy? R squared can go as low as what? Quick review question right here. R squared can go as low as this. R squared could go as low as what? R squared can go as low as this. R squared can go as low as this. What is the lowest R squared can go? R squared can go as low as this. Go as low as 0. R squared adjusted is always what to R squared? R squared adjusted is always what to R squared? R squared adjusted is always what to R squared? Like R squared adjusted, since it's adjusted, will always be this to R squared. R squared adjusted will always be this to R squared. R squared adjusted must be this to R squared at all times. Smaller. So what do you think R squared adjusted can be? Hopefully I've done the example. Oh, we didn't get it. Let me try again. Randomness didn't win this time. R squared adjusted can be what? Which this is a thing people usually don't realize. Since the lowest R squared can go is 0, and R squared adjusted is always smaller, R squared adjusted can be what? Which is why it doesn't really have any good interpretation. It can be negative. And you're like, wait, R squared can't be negative because it's percent of variation explained. Well, this one doesn't have an interpretation. It's a comparison metric. And so since R squared can go as low as 0, R squared adjusted is always lower, and thus R squared adjusted can be negative. So if you get really bad models, you will see negative R squared adjusted. Notice here that we have a really bad R squared, and then the R squared adjusted right here is negative. This just says I'm making horrible models. Notice how it's not statistically significant. So R squared adjusted can be negative, and that's a huge if you see a negative R squared adjusted, you've done some very bad statistics. Like I should not, this is a bad model, this is all randomness, and I shouldn't be including all of these X's right here. So that's what I would learn from this immediately. Just looking at this, if I saw this in someone's output, I would say, like if they said, here's my model, I'd say, your model looks really bad. They'd be like, well, it explains about 1% of the variation. I'd be like, well, 1, your model's not statistically significant. And 2, when you adjust for your R squared, squared being negative is a red flag. Yeah, exactly. Like the idea of a squared thing being negative is like, you can't square something and get something negative. Yeah, it's a red flag right there, just conceptually speaking. And that's why I think also it just shouldn't exist. Like this model literally shouldn't exist. You know what we're going to do? We're going to go here and go to, we'll go to null. Is that how we null it out? Null. Wait. We'll store into our model the null object. And guess what? The model doesn't exist anymore. We say, give me the summary, and it says, I cannot. It is of null class. There is no model. Model's gone. Head back to the main screen. Shreya, great job right there. Excellent work. That's what we want to understand and work on. All that good stuff. Let's check out the next question. We have question number 4. 3:55. Heading over to the main screen. Let's do it. We are back to assignment 3 for time series. We're going to jump right up here to question number 4. We got the TOOT 1 CSV. CSVs are comma-separated values. A comma-separated value is basically just what it says it is. You got a bunch of values separated by commas. That's the way it goes. And they're stored in a file. Let's load it in right here. Make sure it's in your working directory, which it is for me for once. So we are going to store those values in our working directory. And now we are going to store into the first column name a 1. Oh my gosh. We're going to store quarter into the first column name. So column names, we're going to overwrite it with quarter. It currently exists as X. Not good. There we go. Now it's quarter. And then we have right here, we can view it. Cool. You can also view it by doing this. That's my preferred methodology for viewing things. Just taking a look. Looks pretty good right there. It is not a TISBL yet. Who knows for 320? We have 1 watt and 3 watts. Try to answer that question 320 with terminology. Right here we have, which we need 1 of these, which I don't think we can ever have 2 of these. I don't know. Maybe there's weird stuff. Data is always interesting. We have 1 watt and 3 watts. Terminology time. We have 1 what and 3 whats right here. Terminology of how a Tizbol should look. We have 1 what and 3 whats. Just understanding what you have. Always look at what you have. Shreya, good answers right there. Kind of, sorta. So, in the terminology, so if you ever take time series, you're going to get some advantages here. So check it out, and if it catches hold, remember, we call this the index. And these are measures. And the measures are quantitative. That's exactly correct. And you are right. That is a character, which is kind of categorical at the moment. We're going to fix that. So Shreya, I'm throwing another 100 points. What you said is accurate. We do currently have kind of one categorical thing, like what was the quarter, which is like a category, but we're going to index on that. So we need an index for a time series data set. And the index is the consistent interval of time things are apart. And this is going to be indexed on the quarter. We're going to use a function right here to mutate this. And you'll see the code right here. I think it's already laid out for us. Construct time series plots. And first thing we need to do is we need to store it as a Tizbol. So you notice right here, we're taking the data. It's going to go through this pipe. It just goes boop, 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 boop. And then we're going to mutate the quarter into month, year. So right here, we're mutating it into month, year. And then it's going to be indexed on quarter. So I am wrong. It's not quarter. It is quarter. Well, shouldn't index, right? Let's see if it indexes. So here it is right here. Here's the new thing. And it says 1 day. Dun, dun, dun. It is not happy. It is not happy. We're going to have to fix something right here. Okay. It says month, year. We need to change this. The index proper function. It's not quarter, is it? Is it year quarter? It says I'm mad again. Cannot be expressed as a date type. Let's fix this. I'm going to go over here to the Tom series graphics. It is not pretty right now. Always look at what you have and make sure it is what you want. Let me look at where we're indexing by the quarter and make sure we get it right. Quarterly should be year quarter. That is the right function. And let me go over here to the book and look at where year quarter is used to make sure we use it properly. Okay, so how is the date looking on this? This is the prison data. And so here it is right here. Let me go grab the prison data. A little chill music while we do this right here. There's the prison data. Reading it from the book. And we should have prison data now. And it's a date. And so we need to set it as a date probably. Probably the issue. It doesn't like it. Let me try the following. Combining some packages right here. Lubridate the two data sets. It is month, year. And cool. Okay, that's good. Okay. That's fine right there. That might like. Let's try this. Up. Cool. It's done. Still not sure if I'm looking at the right input on Q4. Which part of this right here, Shiv, are you talking about? So we fixed it. There's about a billion ways to fix things, but make sure what you have looks right. Does this make sense? Construct time series plots for each of the 3 series. It's not mad anymore. It's not mad. We fixed it. Lubridate is something we talk about in 474. Any methodologies you use, the book is going to be your best friend a lot of times. Please always remember to check out the book. FPP3 is such a great book. Working with Tizbols can be a little bit weird at times. So I'm going to put the FPP3 link in the chat right here. I went and grabbed this, double checked the format. Ayo, Adam, good to see you here. But there's about 1 billion ways your code can explode, and working with different objects requires different codes. So I was like, well, I am using the right function. And then I just wanted to check the format his data was in originally, and I got my data to look like his. That's what I was doing when you look over here at me looking at what the prisoner data looked like and being like, okay, I know what the prison data looks like. It looks like this. I need to get my code to look like, my data to look like that. And once I get my data to look like that, I can see I have the proper index. So make sure you have everything indexed properly right here. This is very important. We need to get this to look like this. So we need to get our data to look like this. This is what is key right here. So all this stuff right here, as it do it right here, I think we're fine. You can remove the facet grid, yeah. I think it's basically Matthias longer. Well, cool. Here we are right here. Now, you might not be able to see what's going on here. Briefly explain any patterns you see. Auto. Let me go to the... I'm going to use the original data. Let's go to the toot one. And let's go to auto plot. When it's mad at it again. Oh, that's not the toot one we're looking for. We're looking for this. Okay. That's one of the series. Yeah, there's not much going on there. We have the 3 different series inside of here. We've got here sales, ad budget, GDP. And once again, think about what you're going to use to communicate stuff. Yeah, awesome. Anytime, Shreya. Great work today. Ooh, what's that? Probably need to talk about that. Let's go here, copy code. Once again, we love the code for this reason because we can go to GG season plot. That's something to communicate right there. Oh, that one doesn't follow the pattern. Yeah. That is very consistent. This is like one of the most consistent seasonalities right here, where this one is more variation within the seasonality pattern, but still Q3 shows that. This one has much more consistency within the seasonality pattern. And then this one right here is showing not a totally different relationship from the other seasonal patterns. There's a really cool one, which I didn't do in last class. It's a circular plot. Oh, I think it's an argument in the GG season. What is the argument? There's an argument you can do. I didn't do it last class, but it is polar. So you can see if there's been like an increase or decrease by doing the polar. That looks like a heart. And you can see the increase or decrease. That one's way more consistent. Looks like some growth in the, like some sort of steady increase, maybe not so much. And then that is a reverse right there where July. So all we're trying to do with this is find ways to communicate what's going on right here. There's a lot more consistency with the ad budget one. So the seasonality there is very, it really just drops in July Q3, I believe it is. All our goal is right here. Does this make sense, Shiv? That we are trying to communicate these ideas. Think about how you can write this, and you might even do something like, I wonder if this would work. Let me think about this. I'm going to display this. Par inflow. I always forget this. I should stop looking it up and try to do it by memory. Par mflow in R. Graph 2 images at once in R. Par mflow. Flow. I'm going to do this right here and I'll do the next one. I know how to do it. It's the par mflow, but I always forget. It's like parameter mflow. Here, wait. No. 2 images in plot window in R. A little music right here. Music just inspires me to do it. There it is. Someone put it on the screen. Par mfro. What is it? Mfro stands for... I don't know what mfro stands for. Not help if I knew what it stood for. Okay. We want 3 columns. What? Change my power flow. Parentheses. Maybe it doesn't like that. It doesn't. I knew it. I knew it. We want to do. There's another way to do multiple ggplots at one time. I got to do that. So I have to do the multiple ggplot methodology. So plot multiple ggplots in one window, in one plot. There's a quick way to do it. Here we go. Someone's doing it right here. GGArrange and pubr, ggpubr. Where's the GGArrange? GGArrange. Okay, it's in ggpubr. Here we go. So we're going to go to GGArrange, and we don't need a plus on that. And then we're going to call this I wonder if I could just, I wish it would just say like something in the top left corner. So we're going to call this P1, P2, P3. I'm going to put this here. No, it's not a ggplot. And we'll just make this P4 for symmetry purposes. Labels, sales. We're doing GDP twice. I would think of something extra to put here if I'm going to communicate this. And we need to load up ggpubr. Could just write that. Okay, that's got that. And then library ggpubr. P1 not found because I didn't save any of these. There we go. So there we go on how to get all the images on one thing right here. I'd find something else to put in the GDP section where we have a multiple GDP. I should be able to, you know what I could do? Is we got a facet grid of all of them. So let me go right here. Let me see if I can save that facet grid with all the plots. And the auto plot facet grid should be a ggplot. So we'll call this facet. And that should, in theory, theoretically, yeah, love it. It'll auto resize the screen. I would either, if this does not look good in my knit, I would screenshot it. So we need to change our labels now and say the first one is facet, and then we have the following right here. We don't need that extra plot. So we already had the extra image. But I'm even going to point class today to this to say, I don't know why I did that, to say these are the ideas and the ways we're trying to communicate data. Does that make sense right there, Shiv and everyone? Like, this is how we want to try to communicate data. Now we've got seasonality plots. Like, this is a major moment right here to be like, okay, here's the data, here's the seasonality plots. So we kind of have the within group of each. And then when we knit this right here, we should see how it knits and looks. I don't think I have any. We'll see what happens. I might have some stuff out of order. So 2 seconds here while we try to knit and we see what happens. But this is what we're going towards. We're trying to think about how we can communicate ideas, and we use graphics and stuff to do that. What's it doing? Oh, it's breaking. That's what it's doing. I'm currently just trying to scroll. Oh, Word is getting mad about something. Oh, it's saying, where do you want to save it? Cool. It was just like paused. Okay, you want to save right there? You want to do that? Microsoft Word is just like literally angry at me right now. Okay, who knows what's going on? Okay, wait. Okay, there we go. Okay, is it gonna do it? Line 40 error. It says could not find. Oh, wow. I don't have dplyr methods. Well, wait. Did I not load library FPP3? That should load dplyr. So let's see if this knits now. And it's knitting, it looks like. So I'm going to look at this. If I don't like the way it knits, I would screenshot it. So once again, look at your output after it's completed. Yeah, you want to delete this. If I was turning this in, I'd delete that. That's you don't need that output. I don't need to print that vector. Once again, you can delete anything. So there's that. I might screenshot it. I don't like. Yeah, I would screenshot. So here's where I'm not happy with the way it looks, and I'm gonna take this right here. I'm gonna go down here in my screenshot. I'm gonna grab this. I'm a little bummed that that facet's covering that up a little bit. It's just because there's a lot of graphic on the screen. I'm gonna say that that's good enough right there, and I would vastly prefer that screenshot in comparison right here. So I think that's a much better visualization. It's a little bit smaller on some parts, but kind of communicates the things we were talking about. So this is a really great visualization all in one right here. This was number 4. Yep. We did number 10 and number 4. Does that make sense, Cora? So a lot of times if you're making stuff, you want to think about ways to, if you did one, yeah, we did this in number 10 today. So we talked about some ACF. Here's the timestamps from today at the very bottom. So we talked about what is the ACF stuff right here and all this good stuff. We'll probably end here in a moment, but Cora, does that make sense? And always be thinking about how can we communicate this? Like rather than just putting a bunch of images, we could do some cool stuff right here and be like, let's show the facet grid and then let's show each of the plots for the seasonality on it, where we can see kind of the reverse with GDP, then sales right here, where sales has a high in this period and a low here. Yep. And then think about communicating these ideas. So this is what we do in 201 is we make graphics and then we write communication on them. And this is what we do in 475 is we make a graphic and then we write communication on it. And what I really love is we go from 201, working with like point click software to where in 320, this was all generated by my ideas. So we're trying to always inspire innovation and being like, hey, why not, if we're making individual plots, say like, I don't need to make these individual plots right here. And I can just delete code I don't want. I should maybe leave in that code because it did set up things correctly for me to do this. We don't need that anymore because it didn't work. We had to do the GG arrange, which is in the library ggpubr for publishing GG stuff. We do have office hours in a little bit here. Yep, I'm gonna go grab a little bit of food. We have class here in a little bit. We have office hours in a little bit. Great stuff. Yeah. So Cora, jump into those office hours, ask more questions. But we want to once again figure out how to communicate this information within this data set, and that's the goal right now. Is like, what do you see? Looks to be a lot of the seasonality. We also mentioned some irregular points, which might be that point right there. I think it might have been. There was a spike in GDP in that time frame. Was it GDP? It's jumping out to me right there. So let's go back to that auto plot. You might even do it with the auto plots. Frankly, here's the thing. Watch this. You ready? Check this out. If we take this whole thing right here, and then we take these right here, and we change these to, we got to remove the polar. I bet we can even GG title that. Oh man, I should have thrown a GG title on that. Let me try that on this. So now I'm going to go to auto plot of this. And let's try this. And I'm guessing, there you go. Yep, look. It's there right there. It's in the 1990s or so. Myers Frozen. How you do a force Control Alt Delete, and then so you go to Control Alt Delete, and then you'll go to Task Manager, and then force close. Should save your work. Do you see that point right there, which looks to be in the 90s or so, and it's in July? Yep, there it is right there. That point right there that juts out. That's very odd. It's easier to see in this plot. It's also that one. We probably need to put P2 and then, P3 and then P2. And then we got to change where this is now. And the reason I'm doing this, GDP, is because I want it to go in the order. It makes more logical sense that, hold I wonder if I can remove that on the facet grid, because that's taking up space I don't like. So this is the problem I get into. Facet grid, scales, free Y. So let me try this real quick. I have a Mac. What is that? On the Mac, you want to go to the icon up here in the top corner on the Mac. Go to the little apple, and it's got like, it'll say something like up here. Colton, do you see like the little Apple button? So there's like an Apple button up here, and you want to click the Apple button, and then it's like processes or something. I got a Mac too. Core will be saying it. For number 7, we'll come back and do that a little bit. On the Mac, you want to scroll up to the top left of the screen, go to Force Quit. Force Quit on the Mac. Top left of the screen on the Mac, go to Force Quit. Top left of your screen on a Mac, go to Force Quit. There we go. That's one of the things I try to do is try to be good with Macs and PCs. It helps me, especially in my job. But I'll go back 15 years ago. You hand me a Mac and I'd be like, "What's this?" Man, I knew what it was, but I've tried to get better. So if you are learning Macs and PCs right now, both, you are helping yourself out a lot, because you never know what you're going to need in the future. You might need some Mac knowledge or PC knowledge, but I wouldn't have known that 10 years ago, maybe. Only recently started using Macs, been PC most of my life. I really want that facet grid to not have the labels. Let me look at it. It's the facet grid which is doing the labels, I think. Facet grid, scales fixed, space equals fixed, shrink equals true, label equals this, as Tisbol, switch, drop, margins. Either a logical vector or character or margin or additional facets which contain all of the data for each of the possible. No. I don't want the remove key from facet grid. Oh no. Let me see. Remove labels from ggplot facet grid example. Okay, someone's got an example up right here. Statistics globe to the rescue. I don't want those labels. Well, no, they're removing those labels. Yeah, they already here. Scales. Let's just take off the scales and see what happens. We're just going to see what happens if we take off that scale. No. I just don't want this metric scale thing. I want to remove the key. We'll spend a few more seconds on this. Theme. Okay, they're adding a theme to it. Strip. I don't know about this. Theme. Okay. Does that make spaces? Okay, cool. So we go facet, theme. It didn't do it. One last try out here. See what chat's saying. You got it. Great job. And then Core will come back number 7. For number 7, I have a line of Laplace to compare, and I think it's going to look crazy when I knit. Do you think it's okay if I comment some of them out for Ning? Yep. Or you just remove. You can just remove it afterwards. Oh, they're trying. That's totally different. Moving empty facets. Get rid of facet labels. They want to get rid of those gray boxes. That's not what I want. Moving elements. We'll listen to a song, then we'll finish off with this. No, that's not what I want. Remove legend. No. No. Ooh. This is not going to work. What is Opsin? Why would they use something I have no idea where it's from? What is Opsin? The quest for the perfect graphic. It's in ggplot2. I don't have ggplot2 running. Well, that's shocking. Where's that? It was right here. Why would I not have ggplot2 running? Could not find function ops. Why? It says it doesn't exist. It says it's in ggplot2. Well, we already stuck on that. Not options, is it? Oh, base. Okay. Last try right here. Wait, someone's got this. Oh, someone's saying you used to. Oh, that's great. Love it. I'm using a command I've required. It's changed instead of this. Instead of that, it's like an old version. I should have just read their full thing, and they're saying instead of this, do this. Well, it doesn't do it. Thank you, Cora. I'm flabbergasted. What is the difference between these two plots? We're saying a theme. Oh, they're just removing that. I want this removed. I want that thing over there removed. I like this right here. I like that. I like that right there. Remove key. Remove key in facet grid R. I like this. I cannot figure it out. I think it's like a required thing. Let me go look at the last thing. I am obsessed with getting this done. Okay. No, I want to... When in doubt, edit the function. Oh, you're so mean. Let's look at this function. Ooh. I was running to this where it tries to pull functions that don't exist. GG Proto, I bet, is the next one. By definition. Something happened. Something happened. Also, Meyer says I cannot do ggplot with my current version of R. Cora, message me on Discord. We need to look at that. What did we get? What did we get? The answer is nothing. Well, it ran. Q must be Qsoro. Well, we did something. The something didn't work. It's back. For our quest for the perfect graphic can never be completed. There is no perfect graphic. I don't want that. I'll figure it out. With that, we'll be back here next time. Bye for now, everyone. Cora, message me on this.